All right, welcome to, we're going to convert radicals to exponential and back from exponentials to radicals, so back and forth. All right, radicals can be written as rational exponents and vice versa, meaning the other way. So how this works is our index, the type of radical, square root, cube root, fourth root, that is going to always be our denominator of the exponent. And what the radical is being raised to, the exponent, becomes your numerator. And it doesn't matter if the exponent is inside the radical, it's still your numerator. And the index, the type of radical it is always your denominator of the exponent. So with number one, I'm going to show you a couple different ways to do these types of problems as I go through, just to show you. So number one, it is a square root. So I'm going to have a square root. You do not have to write the 2. You can if you want. I'm just going to write it just to show you that it's a square root. And then the 4 is on the inside, raised to the first power. Now 4 to the first power is 4. So we have the square root of 4, which is 2. Number 2, that is going to be a cube root, because the denominator is 3, so we have to have the little 3. And that is 5 to the first power. We don't need it to the first power, so that's our final answer. Number 3, this is where I'm going to start doing problems a little bit. I'm going to do it a longer way, probably how you might know it right off your top of your head. But then I'm going to show you a much faster way to do these problems. So it's a square root because of the denominator, so that's square root, and it's 6 to the third. 6 to the third is 216. And simplifying the square root, the biggest perfect square that divides out of 216 is 36. That's 36 times 6. And the square root of 36 is 6. Square root of 6. That is the longest way to do this problem. There is a much faster way. So I'm going to take it right from here. So the square root of 6 to the third. You could break this down into, we have 6 to the third means there are 3 6s. It's a square root, so we need pairs. So every pair can come out. So for every pair, we're going to bring 1 out. So 6, there's only 1 pair. And there's a 6 left over, so that's going to stay on the inside of the square root. So 6 square root of 6. There's one last way you could do this problem, and that's not even converting it. So you have 6 and 3 over 2. You could think, how many times does 2 go into 3? And that's 1 time, so that's a 6 to the first. And then there's 6, there's 1/2 left. So there'll be a 6 on the outside and convert the 1/2 to a square root. So there's that way too. Most likely the way I would want us to do this problem is this middle way. Something like that. That would be the way I'd like to see it done. It's much faster than the top way. All right, so let's take a look at number 4. I have a cube root of 10 to the 5th. How many groups of 5? So you can just think how many groups of 5. So I'm going to write it out. But you don't have to write it out like this. You could just think, you have groups of 5. You could hold 5 fingers. How many groups of 3? Sorry, groups of 3 can you divide out of 5? Well, there's 1. So that's going to be 10 on the outside, and it's a cube root of 10 times 10. Well, 10 times 10, we can simplify that to 100. So 10 times the cube root of 100. On the back here, we have number 8. So I want you to work this one out. Try it on your own at this point. But answer-wise, it starts in the parentheses, so I'm going to keep it in the parentheses. So it's a cube root of 5n in parentheses to the 5th power. So you got to think about it as there are 5 of those. How many groups of 3 can you divide out of the 5? So I'm going to write it out. You don't have to do this, but just to visually see it. There are 5, and how many groups of 3? Groups of 3 can we divide out? We have 1 group, So that's going to come out as 5n. And what's left over, we don't have another grouping, so that's going to be cube root 5n times 5n is 25n squared. All right, converting it back, so you're just going back the other way. This is a square root. Square root is 2, so the denominator is 2, and the numerator is our exponent of 1. For this, the only one that might be of issue, it would be the last one. So try it and then check out the answer when I do this. So in parentheses, I always put parentheses around what's underneath the square root or the radical. If it's more than just, if it's just a letter or just a number, then I don't need parentheses. But if it's a coefficient and a letter variable, then I need the parentheses. So it's 5b raised to the 5. That's a square root, so divided by 2. All right, thanks.